Asterfusion PTP switches. Precision time protocol switches deliver nanosecond time synchronization and loss-free transmission over open sonic numbers.
Welcome to The Explainer. Today we're diving into the invisible, yet absolutely critical world of nanosecond network synchronization. To us humans, being a minute late is just a minor annoyance. But in modern telecommunications, being a billionth of a second late is a complete disaster. So let's demystify the Precision Time Protocol, or PTP, and see how Asterfusion's groundbreaking networking solutions are making this extreme precision a reality.
So what actually happens when your network is a nanosecond late? A nanosecond, 1/1000th of a second, sounds like literally nothing, right? But in today's data ecosystem, being a nanosecond late means catastrophic network failure. In a 5G network, your signal drops. In a live sports broadcast, your audio and video drift completely out of sync. When we're dealing with high-speed data transmission over standard Ethernet cables, which are inherently unpredictable and non-deterministic, we have a major physics problem on our hands. How do we get unpredictable cables to deliver mathematically perfect time?
Well, we're witnessing a massive paradigm shift in network timing to solve exactly that. Think of the legacy Network Time Protocol, or NTP, kind of like your everyday wristwatch. It's accurate to the millisecond, which is perfectly fine for basic logging or checking your email. But Precision Time Protocol, or PTP, that is the atomic clock of the networking world. It uses hardware timestamping to hit sub-microsecond, even nanosecond level accuracy. We are literally jumping from measuring thousands of a second to billions of a second. It's a massive but totally necessary leap.
So why do we actually need this atomic level accuracy? Well, legacy timing simply falls apart for today's mission-critical apps. In 5G Open RAN, for example, multiple radio units use a technology called comp to combine signals. That requires absolute, flawless time alignment. Plus, in 5G TDD networks, uplinks and downlinks share the exact same frequency, so PTP ensures they don't crash into each other. In broadcast media, moving from old-school SDI cables to IP networks relies on the SMPTE ST 2110 standard, meaning every single frame of video and snippet of audio has to be perfectly aligned. And of course, things like high-frequency trading or massive cross-data center AI clusters, they rely on perfectly synced distributed databases. Simply put, none of this works without PTP.
Now, the math behind this incredible precision is actually pretty elegant. It uses an end-to-end delay mechanism. It starts with the master clock sending a time-stamped message at time 1. The ordinary clock receives it at time 2. Then the ordinary clock shoots a request back at time 3, which the master receives at time 4. The system basically takes the time difference of the first trip, adds it to the second trip, and divides by 2 to find the exact network delay. It subtracts that delay, and boom, the clocks are perfectly synchronized, totally bypassing the unpredictable lag of standard Ethernet. Okay, so understanding the protocol is one thing, but running it at scale, that requires some serious hardware. Let's talk about the Asterfusion 1G to 800G PTP switch portfolio. These are open networking solutions purpose-built from the ground up specifically for these time-sensitive networks.
What's really cool here is that Asterfusion isn't just offering a single specialized box. We're talking about an entire portfolio scaling all the way from 1G up to massive 64-port 800G OSFP data center switches. But the real headline here is the PTP precision. These switches achieve ITU Class C accuracy. That means their time error is 10 nanoseconds or less. They can natively act as a grandmaster, a boundary clock, or a transparent clock. And they pack all of this into a really compact 1U or 2U disaggregated design.
But look, hardware speed isn't enough if it doesn't speak the right language. Different industries have totally customized PTP to their own specific needs. And Asterfusion supports these multiple PTP profiles right out of the box. For broadcast media, it easily handles SMPTE ST 2059-2 and AES 67. For telecom 5G fronthaul, it perfectly runs ITU G.8275.1 and .2. And for general data centers, it uses standard IEEE 1588v2. But here's the real superpower. It supports concurrent, multi-instance PTP operation. That means you can run completely different industry standards simultaneously on the exact same switch without any domain conflicts whatsoever.
To put that into perspective, think about a real-world 5G Open RAN deployment. You never have just one vendor, right? It's always a mix. Some devices might require full-path synchronization via the G.8275.1 profile, while others only need partial timing awareness using G.8275.2. Because Asterfusion switches support dual domain operations at the exact same time, they act like a universal translator. You get seamless interoperability across varied radio and distributed units, and you don't have to tear down and rebuild your entire synchronization infrastructure to do it.
So you might be wondering, where does that original, perfectly precise time actually come from? Well, Asterfusion uses a really smart, integrated timing architecture. Instead of having separate GPS receivers and clunky timing boxes all over the place, platforms like the CX306P integrate the whole shebang. They have a pluggable GNSS module that pulls exact times straight from satellites. And this is crucial for resilience. This source-level synchronization at the network edge keeps everything running flawlessly even in GNSS-denied environments, like indoor, metro, or underground scenarios. By unifying satellite time, synchronous Ethernet for frequency, and PTP for packet level time into one single platform, you drastically reduce network hops and save a ton of money on external hardware.
Now, precision without manageability, that's basically flying blind. If something goes wrong at the nanosecond level, you need to know about it instantly. That's why Asterfusion leans heavily into automated operations, fully supporting standardized management protocols like netconf, Yang data models, and open APIs. This lets network operators seamlessly integrate these switches with their centralized controllers. You get real-time streaming telemetry, giving you complete end-to-end visibility. It makes troubleshooting incredibly fast, allows for total network optimization, and seriously lowers your operational expenses.
But what happens when the network gets ridiculously busy? Say, during a live broadcast, or in a massive data center with terabytes of data just flooding the network. That's where QoS, or Quality of Service Assurance, kicks in, specifically for timing. Using hardware-based forwarding and super fine-grained queue management, the switch prioritizes PTP traffic above absolutely everything else. It essentially creates an unstoppable VIP lane for your timing packets, guaranteeing low jitter and zero packet loss, so your synchronization remains rock solid even under massive network congestion. And the brains behind all this routing, the priority queuing, and that multi-profile juggling we talked about, that's Asternos. It's Asterfusion's highly optimized enterprise-grade distribution of Sonic, which is the open network operating system originally developed by Microsoft. Asternos comes pre-installed on these switches. It's fully programmable, totally disaggregated, and supports rich Layer 2 and Layer 3 networking capabilities, things like VXLAN, BGP EVPN, and EVPN multi-homing. Best of all, it frees you completely from traditional vendor lock-in. This open architecture means lower CapEx through multi-function integration and reduced OpEx through automation.
Let's actually see this in action. Right now, Asterfusion PTP switches are powering mission-critical timing applications all over the world. We're talking the Austria Open, major European data centers, huge DCI networks, and state-of-the-art live sports broadcast rooms. In the past, broadcast environments were a nightmare of heavy point-to-point SDI cables. Today, they're using fully IP-based networks and the SMPTE ST 2110 standard, running hundreds of gigabits of audio and video right over Ethernet. And because of that 10 nanosecond class C accuracy, every single camera angle, every mic feed, and every graphics overlay hits the production desk perfectly frame accurate. No drift, no drop packets, just flawless performance.
Which brings us to a final thought for this explainer. I want you to look at your own deployments, your own data centers, your own media workflows. Is your network infrastructure truly ready for nanosecond synchronization? Because the demands of 5G, AI, and IP broadcasting, they aren't slowing down anytime soon. They are getting faster, and they're demanding tighter and tighter precision. By ditching legacy protocols and closed-off systems and moving toward open networking platforms with highly integrated, multi-profile PTP like Asterfusion offers, you aren't just solving a timing problem. You are completely future-proofing your infrastructure. I hope this explainer sheds some light on the incredible engineering powering our fastest networks. Thanks for learning with me today.
If you are interested in the Asterfusion PTP switches, we welcome your inquiry. Please contact bd@cloudswit.ch. Asterfusion, leading provider open networking solutions.